In this section, we are going to discuss one of the most important concepts in digital modulation, and it's called inter-symbol interference, or we call it ISI. So what is ISI? And actually, we want to see what causes ISI and how we can prevent it. We are going to discuss these two things. So first, let's understand the meaning of ISI in this video. So we're going to explain the ISI with a very simple language so we can understand the total concept. So first we say that if the communication system does not provide sufficient bandwidth, it will distort the signal. What does it mean? So we start from this point that we said that we're going to have a non-return to zero code, for example, in PSK modulation. You saw this. So this is the baseband data, and this has a low frequency. So what is the spectrum? What is the frequency spectrum for this random pulse, let's say? We saw this, we observed this in previous sections, that it's going to be synced like this. So we have different kind of information here for different frequencies. So now imagine that our channel is band limited, and we know this, we don't have an infinite bandwidth channel. So if you want to include all the bandwidth for this data, as you see here, it means that we need a very wide bandwidth for this. So we can't do that, and most of the time the channel is band limited. We talked about the communication system. We said that we have a channel. For example, let's say here the channel has the bandwidth of 200 kilohertz, let's say, for GSM, for example. So it means that we are limited to the bandwidth, and we can't let all this data to be transferred in the system. And so we have to get the most important part of the data. We said we generally get this part, for example, let's say. But then there's something missing here. So we are actually attenuating this information here. We are getting rid of this information, and this is not good. So we're going to see removing this information here because of the band limited channel is going to cause us a problem. So what kind of problem we have here? It's going to actually, this problem is going to distort our signal, and we are going to see how this happens. So we start with a very simple example. So imagine that our channel is a band limited. What does it mean? It means that we model this. We model the band limited channel with a low pass filter. How? So we go back here. So we said that we are going to pick this. So what are we doing here? We are actually filtering. Yeah, we are filtering the spectrum. And what is this filter? It's a low pass filter. Yeah. So then the band limited channel is going to behave like a low pass filter, and we can simulate this here. So if you have a pulse and if you apply to a low pass filter, you're going to have this kind of shape at the output. So as you see here, even you can use a superposition. For example, the response for the only unit pulse here, as you see, if you have a unit pulse, the response is going to be this. So if the unit pulse is this one, response is going to be, so 1, 2, 3 response. And if we imagine that like the edge here for this one is going to be the negative. So if we add them together, it's going to be something like this. Or it's actually very simple. You can imagine like that. So there is a settling time for this low pass filter. Yeah, this is a RC system, and this RC system has a settling time. So for example, if the RC is low, it's going to settle fast, but if it's high, it's going to settle. It takes time. So it's going to be like this. It can't follow the output, can't follow the input, because there is a capacitor here, and the voltage of capacitor can't jump to this. Thank you for watching our video. Please don't forget to subscribe. You can learn about this topic and more using our website. The complete course on this topic is provided on our website at www.rahsoft.com. Rahsoft is providing a complete certificate on radio frequency. The courses are complete step-by-step approach with quiz and examples, and certificate of completion will be provided upon finishing each course. By taking the required courses in RF system and IC design with pass status, Rahsoft would provide the Rahsoft radio frequency certificate. Thank you. See you soon.